So in the previous video, we did mention that we're going to talk about byte pair encoding, which is used by tokenizers that GPT models would use for their training. So let's just see byte pair. The principles are quite simple and make sense. So we're going to discuss that's the intuition behind byte pair, not the implementation, because the implementation is quite complex. So what byte pair does, it breaks down words that are not in the predefined vocabulary into smaller sub words. I've increased my by mistake. I've increased my brush size again. Okay. So it breaks down words that are not in the predefined vocabulary into smaller subword units or individual characters or even individual characters. And this helps it to handle those out of vocabulary words. So let's see how it does that. It iteratively, so this iteratively merges frequently um frequent characters, if I can say frequent characters, into subwords, and then builds words and words on top of that. So the frequent characters will build subwords. The frequent subwords might end up building words. So it might start with a breakdown of A, B, C, etc. And then it starts merging words based on how frequently they appear. So, for example, it might merge D, and E. So D and E, because in the English language, D and E often appear together as DE. So in words, in words like depend, depend, made, words like made, words like define, you know, because these are frequently appearing words in English, it sees DE as a frequent combination. So it merges DE. Of course, there's going to be a frequency cut off or a frequency threshold where it stops merging, but it merges words iteratively like that. So what ends up happening is if it encounters a word that it is not familiar with, so for example, unfamiliar word, it will break. Imagine this is one word. It might break this word into three like this. It will say unfam is one part, a subword, and then ilia, another subword, and then word, another subword, and give those their own token IDs. So, or another example, let's say we have created our own language that is not known in the vocabulary. What it will do is it will break this word down into characters and then start connecting the characters that appear together. So AK, they appear together in some words. So it will put AK like this, and then maybe the W will stay by itself now in that sequence, in this particular sequence. The IR might go together into a token like this, and then the W again by itself, and then the space, just have space, and then here the IER, like in there. So a word like there, there's IER. And then, so now this is the tokenized text of that sample that I just gave you now. And then here it then gets the token IDs from the vocabulary. Because in the vocabulary, these will now be there in the vocabulary. So now this might have 33901 ID, this one 86 ID, this 343 ID, 86 ID, 220 ID, and then this maybe 959 ID. So this ability to break unknown words into these individual characters, it ensures that the tokenizer can deal with unknown words so that the LLM that is trained with it can process any text, even if it contains words that were not present in its training data. Might not have we have these words like this in the training data because it is a language maybe that we have just made up. But for the large language model to just deal with that unknown word, it tokenizes using this byte pair process. So let's see byte process in code being applied. We are not going to look at the implementation because the implementation is quite complex, but we are lucky enough in Python there is an open source package we can use called TickToken, and TickToken actually implements byte pairs. So we can just use TickToken. We get the encoding for GPT-2. It then gets that byte pair and tokenizer. So that's the tokenizer that we now have loaded in here, and we tokenize our hello. Do you like tea? End of text in the sunlit terrace of some unknown place. We tokenize that. Now hello has been tokenized and all of that, and we can decode it again. We can decode it, and it goes back to the decoded text. And now it doesn't have the unknown. It doesn't have that unknown tag. Hello has been tokenized very well. So that's what GPT uses. In the next one, we're going to build, as you can see, the data sampling. We're going to add a new dimension to this because there's going to be some sliding windows that we need to talk about. And we are now close. We are very close to actually putting everything together. So stay tuned for that video.